Okay, fine. Okay, tell me about yourself, Mr. Sai.
Yeah, actually, good evening, both of you. So, I am Sairam. I have currently pursued my BTech degree in Electronics and Communication in NIT Warangal. I am passed out this year with a CG of 8.81. So, in meanwhile, in the journey, I found myself very enthusiastic in VLSI domain. In more constructively, if I say, I can more correlate with physical design aspects more. If I want to go into depth from my schooling, so I have done my schooling in Sasi school and intermediate also in the same school with percentage of 97.3, and then I got to NIT Warangal through JEE Mains. Uh, and these are my up to now schooling and college. Then at college, I have hold some of my responsibilities with executive member in Science and Hobbies Club, and I'm a national cadet also. And I was part been in the Science and Hobbies, and also Center for Value Education in my college. So I was executive member and then general additional secretary in those two clubs. And then I have done few of the projects which are we'll call as mini projects and major projects at second year and third year. So in second year, I have done one project related to Verilog, where I have built up a uh, train traffic control, where based on the signals, the train should we'll control the train movement by using red, green and yellow lights, where we have designed using flip-flops and also some combination logic. Apart from that, I have done some machine learning projects, but it is not encountered into our VLSI domain. But apart from that, I had done my 2 months internship after my third year in TI, and also 6 months internship prolonged to from 2 months. It's prolonged to 6 months in TI as well. I have done in the 2 months PPA improvement in some of the designs which I have given. Some of them are USB, FSAS, and HSM, and also one is C29 plus. That is C29 plus is in 28 nanometer technology, whereas starting three of them are in 65 nanometer technology. So I have used a machine learning tool which is Cerebrus, which is powered by Cadence. So I have used that, and I have done PPA improvement for all of those designs. So my conclusion on that project is not only based on which kind of VT cells or which kind of PNR improvement, which is already done by Innovus or Genus. Apart from that, Cerebrus, what it actually showcases, what kind of cells we actually use, that will end up resulting in PPI improvement. So I have seen some complex cells called AOI or OI or and inverter cells. These three combination cells, instead of using three different or and inverter cells, we can use this complex cell for PPA improvement. So that is my end result. And also in 6 months period, I have done few of the projects related to, one is on DRV fixing. I have mainly focused on max cap violations. So I have wrote a script automatically that whenever it generates a one line summary, then I need to find out which cells are violating with that max cap issue. If it is so, then why, what is the reason, whether it is due to mainly due to the net capacitance higher, or input pin capacitance of this driving cell, or output pin capacitance of the previous cell. So that these three components should be always less than our max cap of the driving cell, then only the previous cell of this violating cell, it can be able to drive, otherwise it will give the max cap issue. So that on that basic condition, I have wrote a automation script. It directly gives the up to what level we can swap this cell with this violating cell with another higher drive strength cell which is available in the library. That is 1 month period I have worked on it. And next thing is, I have done some I mean, I have done from synthesis to routing. Apart from that, in the power planning, I have constructed a power grid where it should be efficient power grid, where the IR drop should be lower. So I have done some experiments on IR drop, how to reduce it. If it is occurring, then how can we mitigate those issues by using scripting itself. One I have done is, in between the macros, I have found some of the very higher drop issue. So I have reduced the gap in between the macros channel, that so that any cells can't be placed or there won't be congestion issues. One thing I have done that, and also automatically when we are constructing the power grid, then the VDD and VSS metal lines should be constructed along the chip, so that it gets the efficient power and ground signals, so that at the borders of our chip there won't be any IR drop issue mainly. Apart from that, I have done a third project which is related to STA, which I have done constant based on constant validation. So basically, what is you are also aware. We'll have constraints, so we need to validate on our real design whether whether they are actually correct or not. So constraint validation, I have wrote a script, so the tool will, if we get the one line summary, then it directly takes that report and it validates the constraints, whether they are whether the endpoints are really unconstrained. If it is unconstrained, then what is the reason. So we'll segregate into different buckets. Then for the user, it will easy to review the constraints whether they are really unconstrained endpoint or not. If it is yes, then we can directly waive it off, or else we can directly give it to the user input. Again, it will continue the same flow until and unless if we get the valid unconstrained endpoint. That is third one. Fourth one is, I have done synthesis on some of the IPs. So we have IPs, we have some smaller IPs which they contain the clock divider circuits. So I need to code the constraints for them wherever the generated point is there. I need to find out in the structure itself from the RTL, and I need to code the constraint. I need to do the synthesis. And at last, I need to be clean with the check timing. So that is the fourth project. So these are the major projects in the 6 months period I have done in the TI. Apart from that, so these are the projects, and maybe I can end up with this projects part. And then yeah, some of my hobbies are playing games, likely volleyball, cricket, badminton, and I also fond of seeing movies, and I love traveling, and I stay used to be single. I mean, single in the sense I used to be not mingle with any group of members, but I like to be single and reading books, something like that. Yeah, that's about me on a elaborated way. Yes, sir.
So, Mr. Sai, what was my question?
You asked me, you introduce about yourself.
So, you took more than like 10 minutes to introduce yourself. So, the question was very simple and direct. So, when I ask you
Okay.
about, tell me about yourself, your introduction should never cross more than 2 minutes. Okay.
Okay. Okay.
So,
Okay.
when I ask you, right, you should brief yourself. So, introduction
Hmm.
should be, if you open a book, the introduction won't be more than 2 paras. At least
Yes. Yes.
more than, it won't be more than 20 lines.
Yes.
So, you
Yes.
said a half book here.
Yes. Yes. Got it. Got
Where
it.
are you from?
So native is from Andhra Pradesh, sir.
Nah, Andhra Pradesh. That's right. Okay. So, so you did from NIT, right?
Yes, sir.
So in NIT, there might be something like personality development, some programs for your how to attend an interview, what to say, what not to say, how to speak. These might be attended, right? You might be.
Yes, sir.
Mhm.
Maybe yeah, that kind of sessions I have. There are some.
Didn't they teach you what to do with your introduction?
Yes, but actually, yeah, because I was used to some of the campus placement interviews. So they asked us, can you brief on, I mean, can you introduce yourself? So, I mean, on the flow, they'll ask about, can you also continue with the resume what you had kept? So on the flow, I also, I mean, I have already given resume, so I want to also showcase those things. So that's why I have gone on the flow. Maybe from the next time I'll brief on myself with only on my personal details.
Okay, fine. So we'll come back to the main topic now. So you
Okay.
said all of this, right? So you said you have done some projects with respect to the VLSF in your bachelor's, right? So can you tell me what made you to choose this VLSI? And you said that you are interested in physical design, some part from bachelor's only. So what was that main motive to get into physical design? Why not RTL design? Why not the other things?
Okay. So first question is, yeah, I have done some project related to Verilog in the bachelor's itself. That is a mini project kind of. So actually, we need to do write a Verilog code on a traffic light controller. Actually, it is based on some conditions. First condition is, I mean, there are three conditions actually. First condition is we'll have four kind of trains. One is super
No,
fast.
don't explain your project. Like
Okay, okay,
VLSA, how did VLSA come into this game? So what did you use it? Did you write the code using
correct.
Verilog? Is it that what VLSA you are calling?
No, no, I'm not calling it as a VLSI project, a Verilog project.
Okay, Verilog. So you consider Verilog as VLSA or not?
Yes, correct. VLSI.
Okay. So did you simulate the waveforms for them?
Yes, sir. We have simulated.
So you have the numbers of timing of them. I
Uh,
mean, did you
I,
get to know what numbers was the timing numbers of those projects?
so you're asking me whether you had done synthesizing of them.
Simulation. So if you run a waveform
Yes, yes,
with respect to some particular values, you would get an output, right?
correct.
So what are the numbers? Numbers are you once when you implement that? So you set the
Mm,
traffic light simulations, and you are going to
yes,
get an output, right?
yes,
So
correct.
if you get an output, at what second the green changes to red? At what second the red changes to yellow? So what is
Okay.
the duration? So how fast it was?
Correct. Okay. So we have given in the test bench at every 5 nanoseconds, it need to change the light. So at every frequency, at every 5 nanoseconds, the red. I mean, first it will be red, and then it will be yellow, and then green. So this was the duration, 5 nanoseconds.
These are all the test bench work, or have you done anything on the like real implementation of this?
No, sir. Real implementation we have done. We haven't done. Only test bench.
Okay, fine, fine. Now we'll come back to your internship. So you said you have done your internship in TI, right? Texas
Yes, sir.
Instrument, if I'm not
Yes,
wrong.
sir. Yes, sir.
Okay. Tell me, what was the role of yours? Like, what area did you work in Texas Instrument as an intern?
Yeah, in the physical design areas. Or else you want me to detail on it?
You said physical design, right?
Yes, sir.
So, like, you worked on any project, or you just observed the flow there?
I mean, not on active project, but they have assigned me some I mean, so they have assigned me some work.
Okay.
That project is not part of the team, but
Hmm.
as an intern, they will. I mean, you also know, so they will verify. I mean, they
Hmm.
will evaluate our performance based on our what kind of performance we have done so far in the 2 months. So for that sake, they have assigned a project called PPI improvement using Cerebrus tool.
Okay. So you, what tool did you use? Innovas or FC
I mean, okay. So actually,
for the
Cerebrus
flow?
doesn't involve any Innos or
Sorry,
FC.
which one?
It
Which
is
one?
a Cerebrus, sir, cadence tool.
Yeah, but cadence. Okay, fine, fine, fine. Okay, fine, fine, got it. Now we'll move to the next part. Okay, so you said you worked for 2 months there, right?
Yeah,
For
2 months.
internship.
Correct.
And then you said something 6 months or 8 months,
Y-
something.
Yes, sir. 6 months.
So initially it was 2 months, then they extended it to 6 months.
No, sir. Actually, what happened is first 2 months is for performance. So they have
Mm.
selected me on 2 months period on
Mm.
basis. Then they given me optional that you if you want to do for 6 months also you can come. So that's why I have selected for that also.
Okay, now tell me. So you said you done with the serverless tool. So what all you
Hmm.
did? What all the major aspects you did with respect to your
Okay.
design there?
Yes. Yes, sir. So actually, basically, Cerebrus is a tool. I think, can I explain on Cerebrus what actually on
No,
brief on it?
it's I'm not. You said physical design, right? You said you worked on
Correct.
a project. So you worked on flow or you worked on project?
Not on flow project.
Project. So
Yes.
what was your instance count? What was your port numbers? And what challenge did you face with respect to the first flow? I mean, first part of the flow. I mean, first part of the project. Can you
So
explain this?
so actually, I mean, I can't remember the fan in what are the instance count and all, because it was already 1 year back. But I can say some of the problems I have faced
See,
while
I'll
doing
tell you one
Cerebrus.
thing. Been more than 3+ year, okay, in this industry. I can still
Okay,
say
okay,
the instance count, macro placement. I can literally exactly draw the things that I've done three
okay,
years ago. Okay.
okay,
So
okay.
okay, fine. Every detailing is not necessary. At least you need to know the basic things, right? Because you remember what tech node you worked.
Yes, sir. Tech node, I was able to
If
remember.
you remember the tech node, you need to know the instance count. You need to know the metal layers. You need to know the port numbers, so that in the next future, if you are facing the
Yes,
similar kind of block, it will be
yes,
helpful, right? The learnings from here
correct,
will work there.
correct, correct.
Mhm.
But ideally, what I want
Okay,
to,
fine.
yeah,
We'll go. Okay, fine. I'll ask you a very direct question, so instead of asking you to explain. So, okay, what are the challenges you faced in your flow plan?
floor plan. Okay, so I mean, it was already PG design, so they given me again that design, same thing, to just to get to the flow. They wanted me to run from synthesis to post route. So in the floor plan stage, there was notches actually whenever they are placing the macros there. So due to notches, there were we can only place those macros at that position, not on the other positions. We can't do the free macro placement around the chip and do some of the experiments related to the which positions will be suitable, or which position is optimized way for macro placement in the chip area. So because of those notches present, we are able to place only macros at certain position. That was one issue. And
You made a macro placement or not?
I mean, not manually, but they have a script already to place the macros, so that I use it directly.
Go ahead. So let's stick to the point, Mr. Sai. Let's stick to the point. What I'm asking. If I ask you a question directly to the point, you answer to the point. Okay? Because assume if I'm going to take an interview tomorrow in the same in any other company which you have applied. Okay.
Mm-hmm.
And at that time, if you we don't have much time. There will be 100 people waiting for the interview, and out of
Correct.
them, if I give you 2 hours, it's not a worth. I need a candidate who need to answer precisely and to the point.
Okay.
I know PD because I have worked, right. I know PD how it
Mm-hmm.
works, so I don't need explanations. If I ask you
Okay.
to explain, that is when you need to do, right.
Okay. So
Right.
you,
We'll
yes,
stick
sir.
to the
Yes.
point. Okay. The question was challenges. What challenges did you face in your flow plan?
So I think major challenges I couldn't see because they already PG'd the design. Whatever the
Fine.
scripts I was used. So I didn't find major challenges.
Okay. Fine. What else?
Uh, in the challenges part only, what else, or else in the project, whole project.
Next step. Next step. I'm asking you the next step.
So after the floor plan,
What next?
it will be our power planning,
Okay. So,
and then yes,
huh,
sir.
tell me what you did in your power planning. What challenges did you face? What were your responsibility in power planning?
Okay, challenges same for every flow because they already PG'd. I didn't find major issues in any of the flow. It directly went through up to post route.
So basically, you worked on a project which is already done.
Not on this is not the project. I'm saying about the flow. The project is Cerebrus, on Cerebrus.
I think you're confused between the project and the flow. See, I'll give you a clarity. So project means a block will be there which is
Yes,
about to get taped out.
correct.
Okay, so that is called as project.
Okay, okay,
Yeah, that is called as project.
okay, sir.
So in when that kind of thing is there, when we call it as a project.
Okay, okay, good.
Okay,
Okay.
so that needs to be taped out. Okay,
Yes, sir.
so the flow means you're
Mm-hmm.
going to work on a flow
Mm-hmm.
which which you are trying to build for a new project.
Okay. Mm-hmm.
Okay, for a new project, assume you are working on a 35 nm, 45 nm project, and
Okay.
you need to implement it in a like you need it to there need to be a new project like 45 nm. You are already worked, and later you are going to use a 14 nm project. For you are going to implement a 14 nm project where you need to develop a flow, a proper flow, which will help you gain the flow grip on it. Okay, for that
Okay. Okay.
you need to develop a flow, means how good it is, how to like get to the grip of it and all. This is what basically the flow works. Okay, so
Okay.
now
Okay.
you tell me, now you, I guess you got a clarity.
Yeah.
Now you
Okay.
tell me,
So
what did you work on?
yes, sir. I didn't work on the flow. I
Hmm.
worked on, but it is already PG'd. So I was using. I need to do up to post out. That is my basic. What we say at the preliminary level of the project. I have done that, and at remaining, I used Cerebrus tool to get PPI improvement. Cerebrus uses some machine learning settings. So internally it uses. So I need to work on Cerebrus tool to get used to it.
Fine,
That
fine.
is my internship project, internship work. I can't call
Okay.
it as a project also because I haven't done PG of that
Okay, okay,
any
fine,
design
fine, fine.
project.
So you, this is what you have done. Fine, okay.
Yes,
Now
sir.
tell me, in placement stage, what did you see? What all the reports you observed? What was the challenges you faced there in placement stage?
So in that sir, okay, I'll maybe, but sir, so challenges I am able to say only because the same answer, because major challenges I haven't found in any of the flows, sir, because it is already we already have the automation scripts ready. So I used
Did
that.
you?
So yeah.
Okay, wait. I'll ask you the direct question. You didn't face any congestion in your placement?
Okay. Congestion. Yeah. Okay. Maybe I was not able to recall, but I think there are some congestion issues, sir.
Yeah. So how did you resolve them?
Ideally, so because at the starting stage, I haven't resolved any congestion issues, but
Hmm.
at practical level, I didn't resolve any congestion issues, sir.
You didn't do any congestion issues.
Yes, sir.
You're
I
saying you
mean,
didn't.
not
Hmm.
any, I mean, any kind of violations I haven't done at the basic level because I didn't have that much knowledge at that point.
Hmm.
But at a not at a practical level, but I can say what I know, explain how we can do general way
So
to.
basically, you have just ran the flow
Yes,
more
correct,
than
sir.
one or two times. That's it.
Yes, sir.
That's
Yes, sir.
called flow flush.
Flow flush. Yes.
Yes. So no practical work on the block.
Yeah, the entire on the block, no practical fixing. Some of the fixing that I haven't done.
Okay, fine, fine. Now we are able to understand. Fine. Okay. So now tell me. So okay, now tell me what you did in your placement stage only. Let's get there.
Okay. Uh, Placement stage will maybe I can able to first we will at the core area we need to. So can I explain what happens in the placement stage on
No,
briefly?
no, no, no need, no need. I don't want knowledge.
Okay.
I need to understand how much you know. So the thing is, in
Uh,
placement stage, what
uh,
are the like what you did in your flow? What in your flow? What you did, or what you did in TI in placement stage?
yeah.
So they
So
gave
what I
you
did, and
they gave you a script. You just ran it and you get a result. That is what you did.
yes, sir. Yes.
So that's it. They gave you some set of scripts. You
Yes,
ran
sir.
them and you got a
Correct.
result. That's it.
Yes, yes, sir. Yes, sir.
Like connecting one node to another node, it will give you output, right? So it has it
Hmm.
completely done its run or not? That's it.
Yes, sir. It has
Just
completely
like
done.
setting the memory, is it how much memory it is taking? Is it completing or not? This is what you have done.
Yes, sir. On the flow. Yeah.
Yeah, this is what you have done. Okay, fine. So in placement, you have done only this much, nothing more than that.
not on placement only, but every flow, every stage, only just to get the flow what it actually does in the log file I have checked, what are the steps are being in the placement and the routing and CTS. So to get used to what in each of the steps, what else are doing, they give me
Hmm.
some script. So I had run that to get idea on it how actually goes, because I'm in the
Okay,
sec.
now tell me. So
Hmm.
you have said this. So in your placement stage, you have
Hmm.
got the script, right? Have you ever checked it? What is happening in that placement stage? What commands they are using? What
Yes,
happens?
sir. Yes, sir. I can able to tell some of the comments which I have. One is uh, place opt they have done. I mean
Hmm.
at the last stage, but at the starting, uh, mm, comments. So standard cell area. We need to place the standard cells in the core area, and also we need to place the fillers physical on the cells. So we need to actually there will be some inputs from floor plan dev will have, and then SDC file will have, and
No.
also
We'll stick to the question. We'll not go to input files, etc. We'll stick to the question. Question was very straight. You
yes,
know what?
correct.
What
But I
was the
am able to
question? The
recollecting what are all outputs from
question
floor
was,
plan. Then
I asked you, have you checked the these things like have you checked the script?
are there any comments in the script?
Scripts. So I'm asking you. So have you opened it or not? Let's be cut to cut answer. Have you opened the script?
Yes, I have opened maybe, but I am not able to recollect right now what are the comments. Comments I can't able to recollect right now.
Sai,
Only other than
Sai, assume I'm taking you a right now. It's not a mock interview. Assume I'm taking you an interview.
mm,
Okay. Now tell me why should I select you?
yes, correct. But yeah, because on any real design I haven't worked. Maybe practical knowledge I was not aware of.
So you had the tool in your hand. You had the flow in your hand. You had the
Yes,
design in your hand at that time.
yes, yes,
So you have worked in a very reputed company, Texas Instruments. Not easy to get into Texas,
yes, yes,
and the Texas Instruments hiring is very limited, and they
yes, yes,
fire very limited people.
yes,
So if you have worked there, you need to have the credibility of working there, right? So if I
yes.
ask you why should I hire you, you just tell me one reason to hire you. Just we'll not work on mock. We'll consider this as a practical
Got it.
one interview.
Maybe the comments and all I'm not aware. I thought there will be some conceptual questions. I thought so.
Nobody.
Maybe I need to go through the scripts also. That is
Concept
correct.
wise, people need to understand the concept, but don't have a knowledge of tool. Fine, they'll teach.
Mm-hmm.
You have
Mm-hmm.
done so much, right? So they expect you to take both.
Correct, correct.
Okay, now we are done internship, so you will be anywhere applying for 1 year position, right? One plus
Mm-hmm.
experience, not a fresher.
Yes, sir. Yes,
You'll
yes.
have at least apply for 1 year experience because you have done
Mm-hmm.
6 months of internship plus and other a few times, so it's almost 1 year of experience for you now.
Mm-hmm.
So they expect you to know at least a flow well, at least a knowledge of how it works, right?
Yes, how it works I can able to, but the comments you are asking, so that's
Fine,
why.
fine. Let's leave
Yeah.
the comments. Okay, tell me. So you tell me according to the concepts only we'll go. What
Okay.
exactly happens in the placement stage?
So placement stays. We'll take the outputs from the floor plan.
Okay.
So we'll take those actual inputs and we'll have in the core area at whatever the left out area other than macros. We'll in the assigned area we'll place the cells, standard cells, and we'll
Okay.
sorry.
Just randomly placing the standard cells in the available core area.
Not randomly. We already have a floor plan def. It contains macros information based on. I mean. based on the based on the available from top level, will place the cells, maintaining the PP optimization
This is
on the
what
power.
you have to learn. So, when you open a script in your placement stage, in
Yes.
placement stage, the scripts will have some commands, or at least try to read it by line if you are going for any other company next. Okay.
Mm-hmm.
So, what exactly happens is your standard cell get placed. How
Yes.
do they get placed? They get placed as per the macro placement.
Okay.
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 Communicating standard cells with respect to the similar macro or their family, or we call it in a standard terms as a hierarchy. The
Okay.
hierarchical macros and their corresponding standard cell will get placed together.
Okay.
Okay. So
Mm-hmm.
these are placed initially like that only. Then what
Oh,
happens? You said place optimization, place opt, right? What does
yes,
place
sir.
optimization does? These will place all these standard cells in its legal location, right?
Mm-hmm.
So this
Mm-hmm.
is what happens in placement.
Mm, correct.
So the counter question for this will be, even in if you are answering this, they will ask you, did you face any issues? You should say you have to face. Assume you are saying that your
Mm,
face congestion. You should answer
mm.
this. So how do you answer a congestion question? So why was the congestion? They'll ask you, why did you get a congestion? You need to answer that.
Because
How to
mm,
resolve it? You need to answer that. Tell me, why did you get a congestion?
because if their cells are not placed in a legal positions, then one cell will be might be overlap with another legal position of another cell, so there might be congestion.
Okay, I'll tell you other way. So the
Mm.
cells are placed legal now. Tell me.
Yes, sir.
Legal, every cells are placed legally, but still you are seeing a congestion.
Okay.
So now just
So
define congestion. What do you mean by congestion? We'll go conceptually only, we'll not go practically. Okay, define congestion.
congestion means we the available will have in the routing area, uh, how many are required and how many are available. So if the available routes are less than or equal to required routing wires, then there will be congestion.
Less than or equal to. Less than is fine. If they are equal to, why you will get a congestion?
Not equal to, less than.
So if they are less than the, so how does this works here in placement? How will you work on the routing? Routing comes at the last, right? So as per your saying, the
Hmm.
congestion has to appear at the routing stage, not at the placement stage, right?
But according to the cells, if they over if they if the more number of cells are placed, yeah, congestion. But we'll have also pin congestion, cell congestion, right?
I'm asking you the placement congestion. We'll go with the cell congestion only. Why?
Yes, yes. Okay, so cell congestion may be due to because it already placed in the legal position. So how do we get now congestion? So okay, once let me, maybe in a small region, if the too many standard cells are packed, then it doesn't have enough. If there is no space for routing tracks there, then it will cause to congestion.
How will you decide routing tracks in the placement stage? Routing
Not
happens.
only correct, I got it, but in the same area, if there are high cell density in a small region, utilization is too high, right there in the small area.
Fine, no issues.
And also, if there are large number of pins, or if the cell contains high fan out in concentrated only in small in one region, then it also might be considered as a cell congestion.
Fine, but see,
Hmm.
you assume you are. Yeah, I have, see. I'll give you a scenario. I have placed the studded cells. Every cells are legalized. Some area
Hmm.
cells are black. Some area cells are not packed. Okay. So, but if I do a report congestion, I find so on so on, I'll get a congestion report where I'll have a high number of congestion in particular areas. Okay.
Okay.
So why do I get there? Just because cells are so much, that is why I'm getting there, or is there any other reason I'm getting a congestion there?
Okay. Apart from the more number of cells, is there any other reason we'll get the congestion there?
No, I agree that cells are there because
Okay.
that is why we are getting congestion. But
Okay.
just because cells are too many, that doesn't mean that there should be a congestion. There are some areas where I have more cells than the other area, but still there is no congestion.
Okay. So there are more cells, but there is no congestion.
There are certain areas where I can find
Okay.
more number of cells, but
More
still no
number of cells.
congestion.
Okay. Okay.
So
Maybe.
tell me
Yeah.
why? Why does the congestion occur?
Okay. So around the macros also, in between the channels of macros, if the standard cells are surrounded by macros or blockages, then also we'll have this congestion issue, because that blocks our routing channels, right, at later stages. So that itself also will, it will also report as congestion issue there.
You worked in TI Bangalore,
Yes, sir.
Hyderabad.
Not Hyderabad, Bangalore.
Okay, fine. Fine. We'll move to the next topic. Okay, tell me about CTS.
CTS. So is that the previous question went through, or do I need to uh, gain the concept on that?
We'll discuss later. Go to CTS. Explain CTS.
Okay. So CTS, we actually use it for building the clock tree structure. So you are asking me the flow or the
Like
concept, right?
you tell me how does CTS works? Explain me.
Actually, will
What you do
actually
and how does
distribute.
it works?
Yeah, actually, it will distribute the clock signal from the source, which is maybe PLL, to all the sequential elements, flops, latches, in a balanced way. So it works on principle that main goals of that CTS are it need to minimize the skew, that is difference in arrival times across the flops, and also control latency, and also to reduce the power. So it uses mainly clock buffers, clock inverters in the CTS structure, and also it need to at the final stage it need to meet the transition max cap, max tran, and max fan out limits.
Okay, so you are saying that from source to sing. So can you tell me what is local skew and global skew?
Yeah, local skew means it is the difference in clock arrival times in between two neighboring flops.
Which
Global
neighboring
skew.
clock?
Sorry, sir.
You said that clock arrival between two neighboring flops, right?
Yes, yes.
So what are the
Maybe
neighboring flops called
not
as?
neighboring, but also there might be some stages in between. But if we can say it is a local skew in between any two flops, but global skew is the maximum arrival time of one clock to the minimum arrival time of another flop in the whole chip. That will call as global skew.
Oh,
Difference of them.
we'll stick to the local skew. We'll go with the questions of local skew. So
Okay.
local skew is said that between two flip flops,
Yes,
right?
sir.
So which one will be the first flip flop? What do you call the first flip flop? What do you call the second flip flop? Are there any
Okay.
naming for them?
Yes, sir. First flop will be launch flop, and second one will be capture flop.
So is it necessary that the local skew has to be between the launch and capture only, or it can be with capture and launch, or it can be with any other flops?
Mm, yeah, there should be, because if you are talking in one clock domain, then it should be launch and clock only.
Launch and clock, the clock arrival.
The clock arrival.
Okay, what do you have to tell about the regenerated clock or a distributed clock?
Okay, regenerate mean divider clocks. You are asking?
Yes.
Okay. Okay, what we call them? You are saying?
Hmm. Like how will this come into the skew here? I just said that between two flip flops, if there is a
Ah,
regenerated clock,
okay.
so how do you get into the picture of skew here? Because as you said, the
Mm,
between from source to both the ends of the clock flip flops, right? The clock
yes, sir.
point will be from one single source to two different ends of your flip flop.
Yes, sir.
Different flip flops clock ends.
Yes, sir.
If there is a regenerated clock, that is divided clock, so how will that
Okay.
come into the picture of skew?
Okay, so in between, in any of the launch and capture, if there is any regenerated flop, then how will you calculate? Is a question
Mm-hmm.
like
Consider the same.
okay. Mm. So right now one clock will be going to launch flop, whereas the clock divided by signal is going to the regenerated flop. Right?
Yes, yes.
Okay. Once can you give me 1 minute to
Okay.
then I think maybe what I was thinking is maybe we need to map to the generated frequency to the original frequency, then only we can consider this queue. We need to map to the our generated frequency to the original source frequency, then only we can able to.
Fine. Okay. So we'll go to the. So what type of tree have you encountered in clock tree synthesis? Like what type of tree have you built? Or what type of tree have you seen? Any idea about them? How do you balance the skew in these?
Hmm, which type of tree? I think it is clock tree structure because I haven't opened the exact practical clock tree structure there, but I can tell you how we will balance maybe by using clock buffers and clock inverters if there is if they are not meeting in terms of setup or hold, so we'll add them in the clock path so that we'll get the minimum skew in between any two of the launch and capture flops. Mm, and also minimize the latency and also other things mixed tran cap and fan out.
Okay, so we are. Have you analyzed any timing reports?
Yes sir.
Okay. Now, can you briefly tell me what do you mean by setup time? What do you mean by hold time?
Okay. So setup time is the minimum amount of, I mean, the time the data should be stable before the clock arrival edge.
What?
Whereas hold,
Repeat it again.
yeah, the time which is that the time which the data should be stable before the clock arrival edge,
Arrival
the
age.
input data. Yes, sir.
What do you mean by arrival age?
I mean, at the sync pin of the clock, at the sync pin of the clock pin, before reaching to that there will be some rising edge or falling edge, so before that edge the data should be stable, so that time we'll call as setup time.
Okay, fine. Tell me the hold now.
So the amount of data, the amount of time after the launch or capture edge, rising or falling edge, after that edge how much amount of time the data should be stable.
Get a clarity and answer the same again. Tell me what do you mean by hold time? Proper answer.
Yeah. uh, yeah, the data must be the data must be stay stable for a short for a time after the capture edge.
Okay. So after capture it, the data must be stable.
Mm,
For particular, what do you call that? You call it hold.
yes sir.
Okay. Now tell me. I'll just give you an example. So there's a clock signal which is having a duty cycle of 50% with
Okay.
the with a full cycle of 10 ns. Okay,
Okay.
one cycle is 10 ns. So now tell me, at what? So it's the clock starts at 5 ns and ends at 15 ns. Okay.
Okay.
Now tell me, what should be the time the data needs to be stable, or it should arrive before what time, and for what time it should stay stable for setup. So at
Okay.
what time the data has to arrive?
Okay.
0
So
to 15 is
mm,
the time scale.
okay.
5 ns, at the fifth ns the rising edge is there. At the 15th
Okay.
ns the falling edge is there. I mean, sorry,
Okay.
at the 10th ns falling edge
Rising
is
edge
there.
there.
At 15th edge
Ah,
it is again rising.
Okay, okay,
Okay. So duty cycle is
okay, sir.
50% now. So tell
Uh-huh.
me at what time at least the
Hmm.
data needs to arrive so that the
Hmm.
setup violation is not gonna happen.
Okay. So because you have mentioned 5 nanoseconds will be the rising edge, let us say the flop will be positive edge triggered only.
Hmm.
So at rising edge of 5 nanoseconds, the data should be, let us say setup time will be some 2 nanoseconds.
Okay.
So before the after the 3 nanoseconds to 5 nanoseconds, the data should be stable. So it should be stable from 3 nanoseconds
Okay. Okay.
per
Good.
setup.
Okay. So now consider the same example. Can you explain the similar way for the hold?
Okay, so for hold, the data should be stable. Let us take the hold time will be 1 nanosecond. So 5 plus 1, so 5 to 6 nanosecond, the data should be stable.
Okay. Assume
Hmm.
now the same thing we'll consider. Now we'll take 2 nanosecond as hold time. Okay. 5 plus 2 is 7. So
Okay.
now we have now both your setup is also meeting, but hold is also meeting. Okay. So
Hmm.
setup is arriving at 3 ns,
Hmm.
where 3 to 5 ns data needs to be stable, and
Hmm.
the hold for hold the data is going to stay stable from 5 to 7 ns.
Hmm.
So now assume this is a meeting path. Setup is meeting, hold meeting.
Okay, sir.
So due to some of the previous data or some setup clock frequency issues and all. Now assume I've just some constraint issue, okay, or some uncertainties. Now I'm going to change the setup time. So instead of 2 nanosecond, I'll make it 1 nanosecond.
Okay.
Okay. So what would you do to make sure that this data is going to stay stable?
So so what you will do in the data path such that the setup time will be meeting is the final
Hmm.
question.
Yes, yes, yes.
Okay. 1 nanosecond we are meeting, but because it is already meeting at the 2 nanoseconds period, right? So if we
Hmm.
are making it to 1 nanosecond, then it is also meeting at 1 nanoseconds time margin also.
Good. So consider the same thing for the hold now. Okay.
Okay.
Tell me instead of two,
Hmm.
the data has to stay for 3 ns.
Okay.
Same scenario, 1 ns at the setup, it
Hmm.
has to stay for 1 ns. Now you
Hmm.
have, yeah, but it is meeting at the 2 ns, like 7 ns, it has to stay stable. Now it has to stay stable for 8 ns for hold. So what would you
Hmm.
do here now?
Okay. Now 3 nano extra 1 nanosecond we have. So we need to add the delay at the data path. Some maybe 1 nanoseconds buffer, clock buffer, not clock buffer. So we'll add some logic logic delay at the data path,
Okay, logic delay.
not logic delay. I mean any buffer inverter or
Buffer or inverter?
not clock
You
buffer.
if you add an if you add an inverter, the logic is changed.
Okay, so without changing any functionality, we'll add some delay in the data
Oh,
path by using maybe buffer itself.
okay, fine. So by adding a buffer, what? So how much the delay has to be contributed? The buffer, how much delay
Right
the buffer
now,
has to contribute?
yes, sir. Right now, 1 nanosecond.
Okay, so with 1 nanosecond, it has to meet.
Yes, sir.
Okay, fine, fine, man. So okay, that's it for today. That concludes the interview. Okay,
Okay, sir.
fine.
So you will be you said some feedback you will give.
Okay, fine. So based on all the overall interviews, so when you're taking, just one advice I'm going to give you, because I've faced these things in the journey of VLS. I've been more than 5 years in this industry. I've taught students for more than a year. I've trained students for more than a year. I've worked
Okay, sir.
in companies which are like, there are some projects where I've worked where you are using your mobile phones in those projects. There are some
Hmm.
projects where I've worked, they have tape out, and those are working very well in the market. So based on that advice, I'm going to tell you very clearly. So once when
Hmm.
you're taking up big names in your resumes, be it NIT. See, there's apart from IISc, the next IISc you can't go after your intermediate, so you can
mm,
only go for IITs. So once when you get into IIT, the apart from IIT, the only thing is NIT, right?
mm,
So if you're taking the big name of NIT, or if you're taking the big name of big players of Texas Instrument or anything, you need to be credible enough to withhold their name. And the people
yes, sir.
expect a lot from you than an average engineering college.
Mm,
Consider any average engineering college. They expect
mm,
a lot from you because they think you are. They know that you are coming from a in a top institute, and they think that you are well versed in these topics, and you need
mm,
more. You are ready for more than what everybody is ready for. So every
mm,
concept you learn should be
mm,
100%.
yes, sir.
Effort should be 100%. Even though if you are
Mm,
not able to meet 100, coming somewhere to 85 to 90% fine, or one or two hints
mm,
is fine. Okay. Second thing is you
mm,
are good at the timing concept. So what I would suggest is that it's up to you, your choice, but based on the interview I took, I would suggest you to go for an STA engineer than
mm,
being a PD engineer,
okay, sir.
because every concept you have explained from in the perspective of PD are not correct
Mm,
and incomplete and not correct. But if you want
mm,
to pursue in PD, I would suggest you to read and learn everything in PD. Everything. I'm going to say everything. From the
mm,
floor plan, partition, pin placement, uh,
mm,
uh, designing of your that is your partition pin placement, macro placement, how the macros are placed, hierarchies of macros, hierarchies of pins, feed throughs, ports,
mm,
what is
mm,
DFT, scan
mm,
chains. Coming for the placement, you
mm,
have to study and understand how the placement of standard cell get placed, what commands they use, place design, place opt, timing driven
mm,
placement, congestion driven placement, DRC wise. Coming to the CTS, what is CTS, how the clock tree is built, skew balancing,
mm,
latency, uncertainty, corners.
okay,
What
sir.
do you mean by a corner? Everything. So these
Mm, mm,
perspective you have to focus. And coming to the
mm,
PV part, you have to know DRC wise some part of synthesis.
yes, sir.
What happens in synthesis? Translation,
Mm,
optimization, mapping, with DFT synthesis, without DFT synthesis. So these
mm,
all concepts if you learn, then you will
mm,
be a PD engineer. So if you
yes,
are
sir.
putting yourself as a PD engineer,
Mm,
I'll tell you one thing: 90% of the market is not here for a PD engineer who will build the floor, who will handle, who is going
mm,
for a flow. Those
yes,
are
sir.
called as
Mm,
CAD engineers, CAD tooling, CAD
okay,
developers. Okay,
okay, okay, okay.
usually PD
Mm,
CAD they'll say, physical
mm,
design CAD engineers. But
okay,
if
sir.
you want to work on a project, assume you are working on a project
Mm,
that is going to be taped out, or assume there is a project that is done
mm,
which you are going to
mm,
work, and if you are trying to do a better PPA,
mm,
performance
mm,
and
mm,
area betterment or power
mm,
betterment, then
mm.
they expect you to know best things like all of this, whatever I've said.
Okay, sir. Mm,
So these are the areas where you need to focus.
okay, sir. Mm,
Every area. So
mm,
you see if you can get a tool, work on the tool, understand the concepts, learn better, discuss with
mm,
people. This you
mm,
do. If
mm, mm,
not, now if you have a chance, if you have a time, take one more masters from any
mm.
NIT or IIT.
Okay,
You'll
sir.
get a tool there. Learn from
Mm,
there. Learn for
mm,
6 7 months completely
mm,
with respect to tool.
mm,
Get master in the concepts and tool together.
mm,
Only,
mm,
none of
mm.
the things balance at a time. You need to know both the things, tool and concept, both.
Okay, sir. Mm,
Only concept, no, you can't. Because even I can
mm,
train a person for only concept, because I'll give him
mm,
20 websites and I'll ask him to read everything one day. He can get a conceptual knowledge. But tool wise, he
mm.
don't know, he can't.
Yes,
But
sir.
only tool if he knows, if he
Mm,
doesn't know the concept, means tool
mm,
wise if he can place a macro, but why he does, if he doesn't know why the macro
mm,
is placed there, if he
mm,
doesn't have
mm.
a conceptual knowledge, I can't do anything. So both
Yes,
are
sir.
necessary. So you
Mm,
can do this. If not, go join any training institute, uh,
mm.
sit and learn there completely. Do that way.
Yes, sir.
If not, if you think you can improve from here, start revising all of your concepts,
Mm,
understand everything. Go ahead.
mm.
These are the only three ways you can do. If there is any other way, you can do it.
Yes, sir.
If
Got
you
it.
do this, then it is easy for you to crack an interview.
Yes, sir. Mm-hmm.
And with respect to the questions, that
Mm.
is what I said. Very limited time will be there. Usually 40-45 minutes of interview doesn't happen.
Yes, sir.
Interview goes for 20 minutes,
Mm.
25-30 minutes max.
Okay, okay.
Your introduction should be 2 minutes.
Yes, sir.
What? My name is so and so. I come from this place. I've done my
Mm.
schooling, intermediate, bachelor's, master's, and course from so and so, so and so. In the process of this, I've done a project in engineering. This project name,
Mm-hmm.
and then come to your the project does this thing. The objective of the project. Come to the next your PD. If you have done any project or if you have done any experience, tell that. Just that too
Okay.
briefly. I've done work
Okay,
on this
sir.
complete PNR flow. The project
Okay,
was
okay.
on this nanometer technology, and I've done this part. So
Okay,
after
sir.
that, you can tell about your hobbies and end the introduction. Just a 2 minutes introduction. They
Okay,
have
okay,
to,
sir.
the interviewer had to be curious about to know about your projects. Only then he will pick those.
Okay, okay.
Otherwise,
Mm-hmm.
assume if 10 questions are being asked to you,
Mm.
assume you have answered eight correctly. So they'll
Mm.
mark 8/10
Mm.
in interviews. Okay, the reviewer will be other person. Assume
Okay.
if you take 20 minutes to explain yourself out of 30 minutes
Mm-hmm.
or 10 minutes to
Mm.
explain, they might
Mm-hmm.
only ask 5 questions for you because
Five
there is no
questions.
time for
Mm.
you.
Yes,
So
sir.
they'll write if you answer two or three correctly there, they'll put 3/5.
Mm-hmm.
Or
Yes,
assume you
sir.
answered both the two, three wrong at the initial only. Two by
Mm.
five
Then
they
two by
will
five.
write.
Ah. Mm.
So you're losing your opportunity.
Yes, sir. Got it.
Understood? So the
Yes, sir.
answer should be also point. See, I'll tell you
Mm-hmm.
one thing. There is two things, two words they'll tell you. Brief, explain.
Mm.
So when they say brief, your answer should be precise to the question.
Yes,
When
sir.
they explain, ask you to explain, you have to explain everything. Assume if they ask me to explain, assume if they ask me to tell me what did you do in your flow plan, can you brief it out? I'll tell very clearly, brief in a short way. So I got this I got this block which had an aspect ratio of so and so. So the ports were on the right side and the macros were placed along the boundaries. I placed the macros based on the hierarchies and the ports nearby, and all the physical unit cells I have placed so and so. This is how my flow plan went. If they ask me explain, then I'll tell my block size was this much. This I first tried to understand how much the hierarchies was there. I had this kind of hierarchy that I placed here. Then I placed it here the ports. After one trial, I understood that the port and the macro are communicating very far. Communication is very far. They are communicating each other. They are far. So I moved it here. This is
Mm.
explaining. So
Okay,
understand the
okay.
difference between briefing and explaining.
Okay, okay.
Okay. So
Yes,
see,
sir.
if they ask you brief,
Mm-hmm.
if your answer is good in the brief only, they won't go ask you to explain. They'll ask you to explain only if they are interested to know more
Mm-hmm.
about that concept, how much depth you know.
Mm-hmm.
Some
Okay, sir.
There are certain types of like projects where you'll be working. One will be power based projects. Some like low power chips. Consider your handheld device or your wearable smartwatch. These are area and power driven. Like you need to work on
Oh,
a low power and area.
okay.
But if you go for
Okay.
networking chips, you don't have
Ah.
any issue with respect to the power and area.
Mm-hmm.
You need to work on
Okay,
a
sir.
performance because assume networking means you need to have the
Ah.
least delay,
Okay,
timing
okay.
driven ones. So
Mm-hmm.
they
Okay.
are worried about the performance. They are not worried about the power or area.
Power
So
and
these
area
way
side.
they ask you. So get prepared for them. You'll eventually get to know about this in the later stage. But for now, I would suggest you to be precise with your answers.
Mm-hmm.
Okay. So prepare
Mm-hmm.
your resume well again. Start working on the concepts. Put those concepts which you know
Yes, sir.
in your resume, not those which you don't know. Okay.
Mm-hmm. Mm-hmm. Okay, sir.
Fine. Fine. Okay. Fine. That's it. Thank you.
Sir, actually, one more to add. So, hello,
Yeah. 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 I'm here. I'm here. Tell.
hello. So actually, I was working from maybe some 3 to 4 months on the STA part. That's why I
Hmm.
was able to answer. But on the floor plan to routing, only have done at the 2 months period, but not too much aware of it. But I'll recover maybe from these feedbacks.
See, that is what I'm telling. See, if you go and assume tomorrow I'm taking a regular interview for you, and if you come there and tell me this
Mm,
thing, there are
mm,
100 resumes in front of me,
mm.
and you're saying this,
Yes, sir.
what I'll do, I'll tell you, I'll say you that better luck next time, prepare well and come back. I won't give you a
Mm,
job
mm,
and
mm,
ask you
mm,
to
mm.
learn at my end. I'll give you a chance to come back
Yes, sir.
next time. But in your place, I'll select the other person. That's it.
Okay.
It's see, company
Correct.
wants the profit, company wants the work done. They are not worried about
Mm,
our
mm,
work,
mm.
our problems. Be it you studied in
Correct.
NIT, be it you studied in IIT, be it you studied in normal college, you did STA, you come from BCom background,
Mm,
come from BTech, BE, they don't care. Company doesn't have sympathy on the candidate. They are only worried about the work.
correct.
People who can give them a
Work.
work well done and who can make them profitable. Okay, so they focus on those
Correct.
things. So that is why they don't listen to
Yes,
any
sir.
of the reasons. They don't entertain the reasons.
Arguments. Yes. Okay, sir.
Okay, fine.
Thank you, sir.
Okay, thank you.
Thank you so much.